Okay. This is your probability review packet. So you're not going to hand this in. This is just for you to complete on your own. And then your test is identical to this. So if you can do the review packet, you can do the test. I'm going to put a Google form down so you can just submit your answers. But here is the answers to the review, and we'll go through them. It says a bag contains 4 white marbles, 3 black marbles, and 6 red. Find the probability for choosing a marble that's not white. So we say it's the complement. That little C means complement of white. Well, if you're not white, that means you're black and red, which is 9 out of, well, that's 7, and 6, 13. You can leave it as a fraction. The directions don't tell you a fraction or decimal, or you can make it a decimal or percent. The next one says find the number of possible passwords with no digits or letters excluded. It says 3 letters followed by 2 digits. So we have 3 letters. You could do like ABC, 2 digits, 7, 8. Well, that you had 26 options for your first letter, 26 options for your second letter, 26 options for your third letter, 10 options for a digit, 1 through 9, or 0 through 9, and 10 options for your last one. In your calculator, you multiply all the numbers together. I don't know why I can't talk today. And that is your answer. All right, part B, 4 digits. You could have done 7, 8, 9, 0. It doesn't matter, but you have 10 options for each digit. And then you have 2 letters followed by 4 digits, 26 options for each letter, 10 options for each digit. The fundamental counting principle says you multiply all of your ways together. So this is 10 to the 8th, because there's 8 spots, times 26 to the 2nd, and whatever that is in your calculator. Number 3, it says there's digits from 0 to 9 that are randomly selected. So that's 10 possibilities. Find the probability that the first number is a 5 or 7. Well, that's 2 options out of 10. The second number is a 2. That's 1 option out of 10. And the third number is a 3 or 9. That's 2 out of 10. So you multiply your ways together. Well, I'm going to reduce these fractions so it's easier for me. And I'm going to get 1 out of 250. The Word document converted weird when it was uploaded to Google. That's one thing I don't enjoy about the Google Classroom, is that it creates into like a PDF file, and this is what it ends up happening. So this should really be shifted over here like this. It just got formatted weirdly when it converted. It says if one point is selected randomly, find the probability that the point is inside the circle. So what's the probability I get a point inside the circle? That means I have to take the area of the circles and put it over the total area. Okay. 1 second. Okay. So the area of a circle is pi r squared. Well, what's our radius? It says our radius is 8. Radius is 8. So we're going to replace r with 8. And we have 4 circles. So multiply the whole thing by 4. All right. And then put that over the total area. Well, total area is a square. Something by something. Well, if our radius is 8, then our diameter is 16. If our diameters are 16 and 16, that's 32. Which that would also mean this side would be 32. And then if it's an 8 and 8 and 8 and 8, then this side is also 32. So it's a 32 by 32. So 8 squared, 64 times 4, which is 256. So 256 pi over whatever 32 times 32 is. Then you can just put that in your calculator and you'll get it says to the nearest percent. You'll get a decimal and just round that to the nearest percent. The next one is number 5. Here's a whole bunch of sets. These got cut off, but what this is supposed to be is an intersection and a union. Intersection and a union, intersection and a union. So it's saying, what is the intersection between A and B? What do they have in common? They have nothing in common. So it's called null. It's a 0. They don't have a 0 in common. They have nothing in common. So it's a null set, meaning they have nothing in common. Here, what's their union? Well, if you put them all together, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just a reminder, you don't have to hand this review packet in. This is just for you. I don't need it. Okay. B and C, what do they have in common? They have a 4 in common and a 10. And here, when we put them together, we have 1, 2, 4, 6, 7, 8, 10. Okay, here, intersection of A and C. Here, they have a 1 in common and a 7 in common. And union is, they have a 1, a 3, a 4, a 5, a 7, a 9, and a 10. It's all the things that they all have. You don't repeat. Like, so they both have a 7. You don't write 7 twice. Okay? So that's page 1. Page 2 is find the probability of getting a 3 in a deck of cards. Well, there are 4 3s out of 52. Okay? I prefer you to reduce it. It doesn't say a decimal, it doesn't say a fraction, but you'd reduce or make a fraction. It's totally up to you. You wouldn't just leave it like this. Probability of a queen is also 4 out of 52 cards. Probability there's black cards. Well, there's 13 spades and there's 13 clubs. So that's 26 out of 52, or half the deck. What's the probability you get a jack? There's 4 jacks out of 52. And if you're like, I don't know these, you could just go on Google and type in deck of cards for probability or deck of cards, and then go to Google Images and they will have, let's see, let's try it. So, whoops, that's a different class. Don't worry, that wasn't yours. Okay, deck of cards. See, and you could just click on that. And you can look at the playing cards there. All right. What's the probability you have a 7? That's 4 out of 52. What's the probability it's odd? Don't even worry about that. Some people consider ace odd and some people don't. What's the probability it's black and it's a jack? Well, how many jacks are black? The jack of clubs and the jack of spades. And like I said, you could use that chart. So that's 2 jacks out of 52, or 1 out of 26. What's the probability pull a card out of a deck? It's a 3 and it's a queen. That's 0. You're never going to get 3 of queens. What's the probability you pull a card out of a deck and it's a jack or it's a king? Well, there's 4 jacks and there's 4 kings, or is more, you add. What's the probability it's a spade or it's a king? That's 17 out of 52. But was there any spades that were kings? Yeah, there's 1 king of spades. So you counted the king of spades as a spade, and then you counted the king of spades as a king. So we have to remove that 1 card you counted twice. We didn't have to subtract here because there's never a jack that's a king. So we didn't count any cards twice. What's the probability of a club? Or you have a face card? Well, jack, king, queen, 4 different suits. That's 12. But how many face cards were clubs that we counted as clubs and as face cards? There's the king, the queen, and a jack of clubs. So we have to remove those 3 cards we counted twice. And then what's the probability you're a black card? Well, we already said that's 26 cards. Or you're odd. I don't even want to do that one because, like I said, some people consider ace odd and some people don't. All right. If an event is impossible, it has a probability of 0. If an event must occur, it has a probability of 100%. The sum of all the probabilities that are possible in your sample space would be 100%. Like heads and tails, 50%, 50%. That would give you a sum of 100%. Okay. Let's see, last page. It says a number cube is rolled and two coins are tossed. Find the probability of each event. That the number on the cube is 2 and both sides are heads. So I get a 2 and then heads and heads. Well, what's the probability you get a 2? That's 1 out of 6. And then you get heads. That's 1 out of 2 and then heads. If you do something and then you do something and then you do something, the fundamental counting principle says to multiply those ways together. Then it says the number on a cube is greater than 2 and the coins show different sides. Well, that means you could have been tails and then heads. Or you could have been greater than 2 and been heads and then tails. So you have to account for all the different possibilities. Well, if you're greater than 2, that's 3, 4, 5, or 6. So that's 4 options out of 6. Tails is 1/2, heads is 1/2. And then or is more. If you're greater than 2, that's 4 out of 6. And then heads is 1/2, tails is 1/2. So this ends up being 1/6 plus 1/6, which is 2/6, which is 1/3, or 33.3%. You may have to pause that, go back and think about that again. The next one, it says a bag contains 6 red, 10 yellow, and 3 blue marbles. 2 marbles are drawn without replacement. It means you don't put them back. Find the probability you get a blue and then a blue. Okay, so how many blue are there? 3, yes, out of 19. But then you get a blue one again, so that's the 1 less, 2, and then 1 less out of 18. Multiply the top, then multiply the bottom together, and that's what you get. It didn't say find the fraction or find the decimal, so you get to put whatever you want. Part B, it says yellow then red. So what's the probability you're yellow? That's 10 out of 19. Red is 6 out of 18. Multiply the numerators, multiply the denominators, whatever that is, and then that is your fraction. 23, if you roll a number cube and you get a 3, what's the probability you roll it again and get a 3? Okay, so we didn't go into depth. If I roll a 3, what's the probability I get it? This line means given that I just got a 3. What's the probability I get a 3 given that I just got a 3? Well, if I roll a 3, does it affect my next roll? No. So this is the same thing as if I roll a 3. This is just 1 out of 6. Same thing. Let's probably get a 2 given that I just got a 3. 1 out of 6. When it would be affected is like up here. What's the probability I get a blue given that I just got a blue? 2 out of 18. If I just got a blue, what's the probability I get a blue? 2 out of 18. We don't really write it like that though. That's when you get to higher math, you start notating it differently. You wouldn't actually notate it like this. You'd notate it like that, but I'm not too worried about it. How many ways can we name this QRST? Could I name it QSTR? I mean, there's so many different ways. So I had 4 options for a letter here. And once I chose a letter, then I had 3 options. Then I had 2 options, and then I had 1. So that's 24 options to name this rectangle. QRST, QRTS, QSRT, QSTR, and so on and so forth. Okay, like I said, this is just for you, so that way you can use this. Your test is exactly the same. It just has different numbers. I'm going to give you guys a Google form to submit it, and then you're good for the week. We don't have a ton of assignments, number one, because I don't want to overwhelm you. And you guys were lucky with 180 because the goal was to get through almost all of your math by quarter 4. So that in quarter 4, we could just really focus on the last little bits and work on keystones. So that's why you guys are so far ahead. So really probability is last. So after this, we're just going to do a little bit of like keystone stuff because I think eventually you will have to take them. We're not taking them this year. But and that way you have these videos. So when you do take them, you can reflect back. So if you have any questions, feel free to email me. You guys are doing awesome. Thanks.